also known as prefix 3. A trie, pronounced as trie or prefix 3, is a data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. Implement the trie class. So, trie class this is our trie class, and our insert word insert string or the word into our trie. This is our insert uh, method. Our search method returns true if the word is in the trie, meaning it was already inserted before, and false if it's not. And this is in Java, but and we're doing it in Python, but it doesn't make a difference. It's the same concepts. So start with string prefix returns true if there's a previously inserted word that has the prefix, and false if it doesn't. So this is our example. Try insert so and we get these outputs. So if we insert Apple and then search Apple, we should get true. But if we search app, we should get false because we don't have an app but starts with app. Since Apple starts with app, then we get true. And if we insert app and we search the try from app, we should get true with app. Okay, so now let's make our node class, a try node class. Class equals to try node. Let's initialize our. Let's make an initialization function. Self. So let's name our dictionary. Let's make our dictionary node that will have the nodes in it. So what should we call it? Self dot equals to children node dot children node. I'll call it child nodes. Children nodes. Child nodes. I'll just call it child nodes. Close to our so self dot end of word marker equals to false by default. False by default. Will hold our child nodes. So let's now point to the to that from let's make ours. Let's point to our try node. Try node. Initialize it. Try node. So now let's get into our function, our insert method. So let's make our node that points to the try node. Try. Nope. So that root since already defined in our class. So for I in word, not word, loop, looping through our word condition if not in, if I is not in, what did I write? not in, not in our node child nodes. If it's not in our child nodes, then let's return false. No, sorry, that's for our search function. Let's add it to it. So node, I'll just copy and paste this to make it quicker and there's no spelling mistakes. Equals to try node class, and then if not in, if letter not in our child nodes, let's add it there. Okay, so now let's move our node to the next one. I'll just copy and paste this here and put node equals to this. So, and then outside our if statement and for loop. So now let's set our end marker and node dot end of word marker equals to false. Nope. True. So now let's so if we put a word inside our dictionary, then we should be able to we should mark it with a true. This false statement was changed to a true. So now let's let me check to see if there's any mistakes. Oops. So the one I can find. So the next value in the I will be the next node. So now let's make our node point to our try node class again. Self.root. So for I in word, I'll just copy and paste this again. So if I not in our child node, return false. So this time it will be false since we're looking for it. Return false. False. And this one over here, let's copy and paste this one too. And this time we should return our end of marker, which will be true if the word is there. If we do make it out of this loop, then without getting a false, we will get a true from this, since we already have the word set to true. So now this one over here starts with, let's point to our node again, try node again, self.root. For I in word, this time, no, prefix. If I not in a word, if I not in, sorry, if I condition, if I not in our child nodes, if so for every I in the prefix, if it's not in it, return false. So it's basically the same as this. And let me copy and paste this. So return to, this time it will return to, this time to return to if a prefix word exists, if the prefix word exists in the nodes. So that should be it. Let me see to see if there's any spelling mistakes or syntax errors. Seems like that should be it. Should be able to run. Let's see if it goes through. Hopefully it goes through. Oops, this one over here. Forgot this. Alright. And that's it. It's been able to run through. Let's submit it and see if it passes all cases. And that's it. It's been able to go through. And this is a time complexity. Best, worst, and average. Best, worst, worst, and average time complexity of O of n, since it goes to it. And that's it for this problem. It's a medium problem, and it's a good practice for trie, for the trie data structure.